This aligns with the practice test for confidence intervals and all of its subtopics. The in-person version is better, but if you can't make that, or if you need a review, then here is the passive version. Here's the list of subtopics that I had generated to align with this presentation. So second, vars, 3, you're going to get to inverse norm. Now, if you have a color version, then you can type in 0.94 and then instruct it to go to the center, and it will generate both answers. If you have a black and white version, it would be the same as the color version that goes to the left. It's just where its default is. So I'm going to change this to left, and it would be the same as the answer in the black and white version. Now there are two ways that you can do this. You can either say that, well, if it's 94%, and that means that there's 6% left for the tails, and then 0.03 would be the left side tail. You're going to get the negative answer there. And then you have to give the positive and negative answers when you answer on your test. The other thing is that if you're a nerd, you say there's 3% in each tail, which means that you're looking at 0.97 right there. And you get the positive answer, but either way, you're going to have to give both answers, the positive and negative, because it's symmetric. This one doesn't really require a fancy calculator, but I'm just not skipping it for that reason. So you get negative 0.7, but the answer should be positive because it's a distance. And if you're a nerd, then you go to the math button in the number menu, and ABS means absolute value, and you can type it in there and you don't have to remember that it's positive. There you go. Since they only asked for the interval and they don't want to ask us about E or any of that other stuff, then we're just going to go to stat, go over to tests, and then number 7 is your Z interval. And we want to ask it about stats. We don't have a data set. We have information like the standard deviation and mean and all of that. So our sigma is 0.78. Our mean is 2.86. And our N is 150. Let's see, confidence. Let's change this to 0.98. Calculate. And then we get this answer, but watch your rounding because your answer should be rounded to 2 decimal places, and it gives us enough information for that. So you should already have the formula, and we're just going to talk about how to get it into a calculator. Sometimes you're provided with a list of critical values for certain confidence intervals, but just in case you aren't, and you need that Z sub C, then second vars and 3. Now, because it's 99% confidence, and also note, I'm going to leave it on the left side in case somebody has a black and white calculator and you don't have the option of making it center. But anyway, so 99% confidence, that means there's 1% left for the tails, which means there's 0.5% in each of the tails. So that's 99.5%, but as a decimal, that's 0.995. Paste. And then that's your Z sub C. So in your formula, you have fraction. I'm going to type in second negative, so it pulls in my previous answer, times 14 divided by 4. I'm going to get out of there, and I'm going to square it right there. And that gives me 81.277 blah, blah, blah. But it doesn't really matter what the point blah, blah, blah is. Even though it's 0.2, I'm going to round up because I can't chop anything off. 81's not enough, so 82 has to be what I use. I always round that one up. There's no fancy calculator skill for this one. This is just a reading question. It's 451. We're finding the critical value t sub c instead of z sub c. So the difference there is we're going to go to second vars, and instead of number 3, which is inverse norm, that's a z kind of situation, we're going to go to number 4, which is a t kind of situation. So the area that we are looking for, if it's 99% confidence, then that means that, again, we have 0.99 and then also 1% in the tails, which means a 0.5% in one of the tails. So I have that. The other thing is my, I should say, I have 0.995 instead of saying there's just that. And the DF, the degrees of freedom, well, since my N is 10, my degrees of freedom is 1 less than that, so that will be 9. So there is my critical value, and I will round accordingly. So I need a critical value, and still assuming you don't already have a list of them given to you, and we need to find one, then I'm going to determine if I need a z or a t, but because I don't have a sigma, I have an s, that tells me that I'm going to need a t sub c, not a z sub c. So the existence of an s means that I'm going to go to second vars, and I'm going to go down to number 4, inverse t, because s is what I use with a t when I have a sample. So I already have the 0.995 from the previous problem, which makes sense still because it's a 99% confidence interval, and then that leaves 0.5% in either tail. But my DF now, since n is 16, then my DF is going to be 1 less than that, so that's 15. So we're here. And then we multiply that by 2.6 over the square root of 16. I know that you know that's 4, but I'm going to type in the square root of 16 just to show where the buttons are. A fancy calculator is completely unnecessary for this one. It's just the part divided by the whole. Just take those two things and turn it into a ratio. Still, no calculator necessary for this one either. I just didn't want to skip it. You're just taking your 15% and you're subtracting 3% for your lower bound and you're adding 3% for your upper bound. And you're reporting them as decimals because that's what we do in statistics. They're talking about a population here, and the population means that I'm going to go back to Z stuff, no longer T stuff, but now it's Z stuff again. And so I'm going to be using inverse norm. So second vars, and then number 3. Now it's 95% because I'm 90% confident. If you have a color calculator, just say 0.9 and then center, but I'm going to do it on the left as if it is a black and white calculator. So 90% in the middle plus an extra 5% for the tails because there's 5% in either tail. I'm also choosing to pick the value that would be on the right because that way I don't have to fix my signs. If I just picked 5%, then I would have a negative 1.6 blah, 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 and then that requires me to do some thinking and I don't want to. So this gives me, if I choose 0.95, and that's going to be my 90% confidence, then that means that I can just use whatever number this is. Now the next thing is the p-value. I usually have a p and as a decimal, whatever the percentage is they tell me, and then the q is going to be the rest of it, except that they didn't tell me what the p was. And if they didn't tell me what the p was, then my best guess is 50-50. So I'm going to put in 0.5 and 0.5 as my p and q times, and I'm going to pull in my previous answer divided by my margin of error as a decimal is 0.05, and I'm going to square that. And I'm going to round up because I always round up.